So, recapping, last week, Nate, pay attention to the monitor there. Okay. Last week we talked about our internet. It went through a rename since last week, and we're calling it the Comicast Internet. And thanks, Roxanne. And okay, so the internet comes into a router, and that's typically provided by the internet provider. And when that happens and you use the internet provider's router, that internet provider most often, or in most cases, will have complete access to your internal network. And you know that if you've ever logged into your internet provider's web page to look at your account and you see, oh, look, I can manage, I can change I can see all the devices, I can manage the router from the web. Isn't that convenient? And sure, that's convenient. But the implication there is if you can access it, they can access it. And while we trust the Comicast internet company because we pay them monthly, we just would rather prefer they not have complete visibility into our network and what's on that network. So what we're doing here is we're designing a network where we're putting the OPNSense or a firewall. It could be pfSense or some other, platform. We're going to use OPNSense because we're fanboys and girls of it. And so we're designing our network. So we have our router. That typically is provided by the internet provider. And then we're going to take another connection from that router. And instead of plugging it into maybe a switch or something else you might have in your home network or your business, we're actually going to plug it into this other router, which is going to create a buffer between the internet and your internal network, and it will give us more control over what can come in and what goes out and what kind of visibility um, there is regarding your network on the outside of that network. Okay, so we have another device here, and we'll talk about that when we get later on down the road after we've designed our network, because we want to make sure that when we sort of put this buffer in place, we want to be thoughtful about what our network needs to do and how we want to configure it and secure it so that we don't spend all this time putting this extra device in place and yet the same vulnerabilities exist because we've not kind of thought about it ahead of time. Okay. And so in this design, you're going to have this OPNSense, and then we need another device of some sort. Now, that typically can be a switch or maybe an access point or something that will plug into, that we can plug into and configure so that we can segment our network. And last week we talked a little bit about what we want our network to do. And we talked about having a guest network. So when our friends and family come over, we can give them Wi-Fi access without necessarily granting them access to everything else. We talked about having an internal network that is for our stuff, like our printers and our computers, our laptops, our desktops, and any other devices. We talked about having some sort of hosting network, and you might be familiar with this in the sense that you've heard the term DMZ or demilitarized zone. And really, technically, all of these are kind of follow the same concept. It's just a way to segment the network. And so we have one of those for future use. So we're gonna design it into our overall architecture. And then in today's age, everybody loves the smart home, and so those devices typically are highly insecure, and so we want to actually segment those off as well. And what this allows us to do, so we have basically 4 network segments, and what I want to do is spend a little time talking about what we might want our networks to be able to do if a device or a person is on that network. So let's start with the guest network, and we'll kind of zoom in here. And let's add a text box. Um, I don't know if this is the right one. Okay, that's fine. All right, so we want our guests obviously to, excuse me, get to the internet. Okay, and the internet is typically port 80 and port 443. Now there are other, oh man, this is not the right, there's a text box here. Let's save this. We'll just do it this way. Text, okay. So internet, which is port 80 and 443 typically. And then we want, actually, we'll just do it like this. Then we want, maybe we want them to be allowed to go out and send and receive secure email, but not actually send email from the network, meaning be able to connect to an email service outside the network. So we're gonna allow secure email services. And then we might want certain, let's say, VPNs, like if they have to get to work, do a work VPN or something, they're spending the night and they need to get to the home network and connect to get work done or whatever, we'll allow that. And there might be a few other things, but for now, let's just keep it simple like that. So we're going to let them get to the internet. We're going to let them maybe send and receive email like IMAP and those kinds of things. We're not going to actually let them send email directly from the network, but we'll allow them, again, to connect to services to send. And then we'll let them get to their work or other home VPNs so that, you know, they can be productive while they're at our wonderful establishment. And then if you have any other thoughts on what you think people should be able to do on the guest network, feel free to share. All right, on the internal network, you know, we'll probably let people do kind of anything they want. So if we have a device, with the exception of a few things. So let's think of the internal network as, instead of what is it that we want them to do, in other words, okay, we're going to restrict everything and then only allow these things. Let's talk about, from the internal network, let's take the approach where we are allowing anything except for a few things. So what are some of the things that we might not want to happen on our network that could get us in trouble? So one thing is, on the internal side, we don't want our devices sending email directly, okay? All right, and so what we're going to do is we're going to block, so no, let's see, let's block services type, okay? And we're going to block SMTP, which is port 25. We don't want them to send email from our network. We don't necessarily want them to be able to, let's see. I mean, honestly, SMTP is the one that gets people in most trouble. Now, we could, you know, there's an argument here where if a device on the internal network gets infected with some virus or something, and then starts using various ports to go out to the internet, that could be a vulnerability. So I'm going to rethink this. I think what we should do is we should actually not allow everything, but we should have a more permissive set of services. So let's say, you know, web, VoIP. What else could we allow? VPNs. let's do web VPN, VoIP, email services. And let's just add one more here, and we'll use we got VoIP, VPN, email. Friday, I'm blanking. Let's see. Yeah, that's good enough. Let's just stop there. You get the idea. And again, if you have thoughts on certain things that we can allow, then please share. But basically, we're going to allow maybe this, one more service in addition to the ones we're allowing on guest. Now, hosting, that one we want to basically lock down and only allow the services that we are hosting. So we're going to come back to that because that's at a later date. Now, IoT network, we definitely want to only allow certain things. So web, okay, and then we want any required ports for the devices to operate, to function, basically. Okay? And that's going to be based on the device itself. So, if we add an Amazon device or some other device, we just want to basically make sure that whatever is required for the thing to function or do its purpose, if it's like a specific port, we're going to allow that. But the nice thing about doing it this way, you might ask, well, why would you segment this out? I mean, you're allowing internet here and here and here. Does that really have an advantage? And the answer is yes, because by separating these segments out, what we get to do is we get to block this IoT network from going to any of these other networks. So while they can get out to the web, they're only going to be able to get out to the web. That's it. They're not going to be able to get to the web on here or here or here. And so it allows us to basically control the traffic going from in and out of the network segments. Now, if we wanted to allow the guest network to get to the hosting network, we can do that. But we can only do that we can only control that if we segment the network out this way. Okay, that's probably enough of that. Let's go, let me save that. Let's go over to this page, and we're going to talk a little bit about IP addressing, just a very little, since we don't have a whole lot of time, and it's kind of a complex subject, so we'll keep it very high level. All right, if you've noticed, we have our guest network is on a VLAN 10. And there's a lot of philosophies around how you organize your IP addresses. But let's talk conceptually about this. So a VLAN, again, stands for Virtual Local Area Network. And think of it like it's basically like a switch. That's a good analogy. So you have, let's go here. So you have a switch, okay? And that switch can be broken up into different segments, okay? And what I mean by that is you can say, okay, we're going to take this port here. You zoom in a little bit. We're going to take this port here, and we're going to separate it virtually from this port, okay? And then we're also going to separate, I'm sorry, let's think of it this way. So we're going to take this port, we're going to separate it virtually from these two ports, okay? So this port, we're going to basically tag it on a specific VLAN. We're going to say, okay, for this port, it's the only thing that it can talk to, the only network it can talk to, aside from its, outside network, or sort of the network domain, they call it. I'm trying to be not too technical here. So we're basically going to segment it and say, okay, this is like its own little switch, okay? And it's isolated from these other two ports, which are their own little switch inside this, okay? Now, another concept is you can actually take a physical port like this, and you can technically allow multiple VLANs on this. So it's kind of like, breaking it up into, let's say we had 4 VLANs and we wanted to say, you know what, because this port connects up to our OPNSense firewall, we need to make sure that this port allows all 4 of our networks. Okay, even though that traffic is going to be separated because they're on separate VLANs, the actual traffic can physically go through this one port in those 4 broken up segments. Okay, all right. So again, a VLAN, it's a fairly simple concept, but if you're not familiar with networking concepts, it might be a little confusing at first. But just think of a VLAN as like a virtual, almost like a virtual switch. So you had one of these and it was broken up into 4 other ones. Okay, and then you basically say, okay, I want these little virtual switches. I want one of them to live here, one of them to live here, and then the other 3 can all live on this same port. Okay, all right. Hopefully that made sense. Luckily, we don't have too many viewers because of the audio issues, but that's fine. Okay, and so we're on VLAN 10 for our guest network, and for an IP addressing scheme, it's always helpful when you are designing your IP addressing to have something that's consistent across the VLAN and the IP addressing. So if we're using VLAN 10, we want probably our guest network to be some sort of .10 network, right? So I'm going to use the common 192.168.1.1/24 that everybody's used to. Everybody's familiar with this. In fact, most devices, like a provider router, they're going to come default like this. Okay. All right, so let's start there. Now, what we're going to do though is, because we want to be consistent with our VLAN tagging, and again, these numbers can be anything, well, not anything, they can be between 2 and 40, technically 4094, but we'll just say 4092. Okay, so between 2 and 4092. That's the VLAN, available VLAN tags on a given switch that you can use, or a network, overall network. And so what we're going to do, instead of 1, we're actually going to change this to 10. Okay, so this is now 192.168.10.1, and now we know that the .10 network represents our guest network. Okay, and we're going to do the same here with VLAN 20. We're going to make that 20. Okay, and oops, just do this 4 times here. Yeesh. This is going to be 30. Okay. And oh my gosh. Come on, Nate. Running out of time here. Okay. And this will be 40. Okay. All right, now, so we have our 4 networks now, and we are going to use the addressing scheme of .10 for the VLAN 10, .20 for VLAN 20, and .30 for VLAN 30, and 40 for 40. Okay, so hopefully everybody knows what an IP address is, but just in case, what an IP address is it is the network address. It's an address, but think of it like a GPS coordinate rather than like a physical address, to use that analogy. So it's a number-based system, and it designates where on the network, an IP address designates where on the network a particular device resides. And so it's used to send and receive certain data, and it's kind of at I think it's layer 3, right? Layer 2, sorry. So it's the you have layer 1, which is the physical MAC address of whatever the device is. Then you have layer 2, which is the TCP/IP layer. Layer 3 is the routing layer. But so we're at layer 2 here, and every device to communicate on the network needs an IP address. Okay, so just think of it, it's a requirement to communicate on the network. And now the other thing that we need to be able to do is we need a way to basically hand out, like if a new device joins the network, we need a way to hand out these IP addresses, and that's what's called DHCP. So let's add DHCP. Okay. Now the other thing is what DHCP stands for is Dynamic Host Control Protocol, and it is essentially just saying, okay, hey, a device joined the network. I'm going to dynamically, let me look at the database and say, oh, I have this IP address. Let's say it's 192.168.10.22 is available. So I'm going to assign that address to this device, and it does that based on the MAC address. And so DHCP is a very important component in these networks. But we don't necessarily want to hand out all of the addresses, right? Because maybe, well, for the guest network, that's fine. But maybe the internal network, we actually have some devices we want to be static, and particularly like printers, for example. So we want to basically, reserve a few IP addresses. So in our settings here, we're going to tell DHCP to only hand out anything from .11 to .254. Okay. And what that allows us to do is then we have basically 9 IP addresses we can use, so that we can assign them to printers or other devices that we don't want their IP address changing. All right. And sorry about the audio issues. It's 10:30, and we're going to stop there. I know that's kind of a sort of a useless stopping point, but we've accomplished a little more, and hopefully next week I don't have audio issues and we can get a little more done. I appreciate whoever joined for joining, and thanks for watching, and we'll see you next week. Take care. Bye.